Hi everybody, welcome back to M Factor. So far, we have discussed about the nervous system and its classifications. Under its classification comes the central nervous system. The topic here we gotta discuss today is about the meninges, the three membranous covering that covers the entire central nervous system. The brain is so delicate that it needs to be protected. This is being done by the bony covering of the cranium, three membranous covering, and the spaces in between them and the CSF. So the three membranous covering are the outer dura mater, also known as the Meninges, the middle arachnoid mater, and the inner pia mater, collectively called as the leptomeninges. The three spaces in between them are epidural space above the dura mater, subdural space below the dura mater, and the subarachnoid space below the arachnoid mater. The subarachnoid space between the pia mater and the arachnoid mater is filled with cerebrospinal fluid, or the CSF. The purpose of CSF is that it acts as a water cushion and also lessens the weight of the brain. The weight of the brain is 1.5 to 2 kg in an adult, and we can't imagine a 2 kg brain over the spinal cord. What happens is that the CSF provides buoyancy to the brain, thus reducing the weight of the brain from 2 kg to just 50 grams. Not only the brain acts as a water cushion and provides buoyancy, it also acts as a shock absorber and provides a shock-free environment for the brain. So let's move on to the detailed study of dura mater. Dura mater is the outermost, toughest and thickest membrane covering our brain. The dura mater has got two layers, the outer endosteal layer and the inner meningeal layer. The endosteal layer serves as internal endosteum or periosteum for the skull bones. Its outer surface is adherent to the inner surface of the cranial bones. The meningeal layer goes in continuous with the dura mater of the spinal cord. At certain places, the meningeal layer falls inwards, that is, away from the endosteal layer, and creates a partition within the cranial cavity, which helps to hold the brain in place and lodge its different parts. The four dural infoldings are falx cerebri, tentorium cerebelli, falx cerebelli, and diaphragm ocella. Falx cerebri. It is a large sickle-shaped fold of dura mater located in the median longitudinal fissure between the two central hemispheres. The anterior end of the falx cerebri is narrower and is attached to the crista galli of the ethmoid bone. The posterior end is broader and is attached to the upper surface of the tentorium cerebelli. Falx cerebri has got two margins, upper margin and the lower margin. Upper margin is convex in shape and is attached to the sagittal circles, while the lower margin is concave and is free. It has also got two surfaces, the left surface and the right surface, and they correspond to the left cerebral hemisphere and the right cerebral hemisphere respectively. In addition to this fold, three important venous sinuses are present. The superior sagittal sinus, which lays along the upper margin, the inferior sagittal sinus, which lays along the lower margin, and the straight sinus, which lays along the line of the attachment of the falx cerebri to the tentorium cerebelli, that's in the posterior end of the falx cerebri. Tentorium cerebelli. The tentorium cerebelli is a tent-shaped fold of dura mater that separates the cerebellum and the cerebrum, and it broadly divides the cranial cavity into two, the supratentorial and the infratentorial compartments. Tentorium cerebelli lies perpendicular to the falx cerebri. As mentioned earlier, between the tentorium cerebelli and the falx cerebri lies the straight sinus. The tentorium cerebelli has got two surfaces, the superior surface and the inferior surface. Superior surface is convex in shape and supports the occipital lobe, and the inferior surface is concave in shape. The tentorium cerebelli has two margins, anterior margin and the posterior margin. Anterior margin is U-shaped, concave and is free. The anterior free margin of the tentorium cerebelli forms the tentorial notch or the tentorial incisure through which the cerebral peduncle passes, connecting the cerebrum and the brainstem. Posterior or the outer margin, it's attached and is convex in shape. It is attached behind, that is posteriorly, to the lips of the transverse sulci on the occipital bone, enclosing the transverse sinus, and in front, that is anteriorly, to the superior angle of petrous part of the temporal bone, enclosing the superior petrosal sinus on either sides. At the apex of the petrous part, the free and the attached borders, both of them meet one another and are continued forward to be fixed to the anterior and the posterior clinoid process of the sphenoid bone. Next comes the falx cerebri. Falx cerebri is a small sickle-shaped fold of dura mater, projecting in the posterior cerebellar notch, that is, the notch between the cerebellum. The base of the falx cerebri is attached to the posterior part of the inferior surface of tentorium cerebelli. The apex is divided into two parts that passes through the sides of the foramen magnum as it proceeds. The falx cerebri has two margins, posterior margin and anterior margin. Posterior margin is convex in shape and is attached to the internal occipital crest enclosing the occipital sinus, and the anterior margin is concave in shape and is free. Next comes diaphragma ocelli, a small circular fold of the dura mater. Completely roofs the hypophyseal fossa of the sella thoracica, a part of the sphenoid bone. Diaphragma also has a central aperture through which the pituitary stalk passes. The attachment of the diaphragma are anteriorly it is attached to the tuberculum sellae, posteriorly to the dorsum sellae, and laterally continues with the dura mater of the middle cranial fossa. So the dura mater has come to an end, and next comes the arachnoid matter. Arachnoid matter is a thin transparent membrane that loosely surrounds the brain. It does not line the brain down to the sulci, with exceptions at the longitudinal cerebral fissure and stem of the lateral sulcus. As we know, it is separated from the dura mater by the subdural space and from pia mater by the subarachnoid space containing the CSF and blood vessels. Arachnoid matter protrudes as arachnoid villi towards the outer membrane of the dura mater. Arachnoid villi are small finger-like processes that project into the venous sinuses. They absorb the CSF. As we grow older, the arachnoid villi enlarges in size to form pedunculated tufts called arachnoid granulations. Pia mater. Pia mater is a thin vascular membrane which runs close to the brain. It lines the brain down to all the sulci and all the irregularities. As pia mater is vascular, the folds of the pia mater enclosing the tufts of capillaries form tela choroidea. Such pia mater, lined by secretory ependyma, forms the choroid plexus.